In this video, I'll explain what significant figures are, why they're important, and how to count them. First, we need to talk about the definitions of precision and accuracy. Precision is about how close measurements are to one another, or how repeatable they are. It's also the exactness of a measurement. On the other hand, accuracy is how close a measurement is to a known or standard value, basically the correctness of a measurement. When playing darts, you could be accurate, precise, neither, or both. In dartboard A, we see that the darts were not thrown accurately. They're not close to the bullseye. The darts also weren't thrown close to one another, so they were not precisely thrown. Dartboard B has darts that were not thrown accurately, but they were thrown with precision because the darts are all close to one another. Though it wouldn't get you many points in a darts game, Dartboard C actually shows arrows that were thrown with accuracy because their average value would be right in the center of the bullseye. However, because the darts were thrown all over the place, they were not thrown with precision. Finally, in Dartboard D, we see darts that were thrown with both accuracy and precision. So what does this have to do with significant figures, also called significant digits? Significant figures indicate the precision of a measurement. And in any measurement, one of those significant figures is always uncertain. It has to be measured or estimated. The line drawn is certainly in between the 4 and the 5 on the metric ruler. In fact, it's just about halfway between them, right on that larger line in between the 4 and the 5. That line represents 4.5. However, I have to estimate whether or not it's exactly on the 4.5 line, if it's a little bit more or a little bit less. I'm not exactly sure, but I think it is a 0 there. So my measurement is 4.50, and that 0 was estimated. Perhaps it's 4.51. Maybe my measurement should be 4.49. 4.50 is my best guess given the instrument that I have. The measurement 4.50 centimeters has 3 significant figures. Significant figures are important because it lets someone know how precisely something was measured, and also the margin of error, in this case, plus or minus 0.01 centimeters. How many significant figures are in this volume measurement in the picture below? The water is clearly below the 25 milliliter mark, but there's no other marks on the beaker. I can probably estimate that the volume is about 20 milliliters, with one significant figure. And that value is plus or minus 10 milliliters. The volume could be closer to 30 milliliters, or closer to 10 milliliters. It's unclear using this beaker. This measurement only has one significant figure. When we pour the contents of the beaker into a graduated cylinder, the measurement can be more precise. The liquid is clearly somewhere between the 18 milliliter mark and the 19 milliliter mark. I judge that the line is 7/10 of the way between 18 and 19 milliliters, so my measurement is 18.7 milliliters. This measurement has 3 significant figures, which means it's much more precise than the measurement using the beaker. So how do we count significant figures? Well, if there are zeros, it can be a little bit tricky. The answer depends on whether or not the number has a decimal point. If there's no decimal point, count the numbers from the left. If there is a decimal point, count the numbers from the right. If a number is not a 0, it's definitely significant. If a number is a 0, it's significant if you've already approached a number that's not a 0. Let's do some example problems. 3.010 grams has a decimal point. So, we count from the left. Counting from the left, the first number that we see is a 3. Since that's not a 0, the 3 is significant. That also means any 0 after that 3 will be significant. So, 3.010 has 4 significant figures, or sig figs. 0.0910 grams also has a decimal point. So, we count from the left. The first two zeros that we approach are not significant because we haven't counted a non-zero yet. Those are just placeholder zeros, making the measurement small. Then we see the 9, which is significant because it's not a 0. Any number after the 9, including zeros, would be significant. So, this measurement has 3 sig figs. 120 grams does not have a decimal point. So, we count the numbers from the right. The first number we see is a 0, so that's not significant. It's only a placeholder 0, making the measurement larger. Next, the 2 and the 1 are significant because they're not zeros. So, 120 grams has 2 sig figs, the 1 and the 2. As a final example, let's look at 305 grams. It does not have a decimal point, so we count from the right. The first number we see is a 5, which is significant because it's not a 0. Any number after that, including the 0, is significant. That means all 3 of the digits in this measurement are significant. And this measurement has 3 sig figs. Pause the video for a moment and practice these 5 problems. How many sig figs are in each measurement? How'd you do? Remember, your first step is always to figure out if there's a decimal point and which side to count from. Zeros are only significant after you've counted a non-zero. It's important to know which numbers in a measurement are significant because that tells you about the precision, or how exact the measurement was made. Well, there you have it. That's what significant figures are and why they're important.